Welcome back to the session. I was telling you that when you refer the um, label REF4 and we have the expression NDA minus list A plus list C, and NDA and list A are defined in this control section, and list C is not defined in this control section. When there is a symbol which is not defined, it's an undefined symbol. When you have the undefined symbol, what the assembler does for creating the object code. So this is the question I have put forward, and the answer would be in the pass 1 and pass 2 of the 2-pass assembler. When the assembler processes the source program to convert into the object program, it generates the object code whenever there is a label which it could not find it from the symbol table. That means if the symbol is not defined in the program, then it's considered as an undefined symbol. When there is an undefined symbol, it keeps the value 0 for the undefined symbol. So when it keeps the value 0, that is that proper value? No, it is not the proper value. Since it doesn't know the value of list C, it keeps a value as 0. When it keeps a value 0, then the NDA minus list A expressions will be evaluated as NDA has the value 0054 and list A has the value 0040. So when you subtract 0054 with 0040, you might get 0014. Now, this is the value for REF4. With this, when you add 0, it is not going to be changed. So, same 0014 is the value for REF4. But frankly speaking, is this the object code correct? Not at all, because we skipped the value for list C. So the assembler assumes the list C is not there. So it assumes 0 and it has been added to the existing value. So it gives the value as 0014. But it is not the actual object code. It is the object code which is derived from what is existing. So definitely there must be some changes need to be done in this object code by understanding the expression. We could make out that yes, of course, there is a change to be done in the object code. So this is one situation in program A. Now we'll move on to the program B. Let us take the same example, REF4, and we have the same expression NDA minus list A plus list C. And all these symbols are not defined in this control section because this program is program B and we don't find any of these symbols are defined in this program. There is a symbol known as list B and one more symbol end B. Those are defined in this program, not these symbols. So NDA is not defined, list A is not defined, list C is not defined. As per the previous program, what the assembler will do, it will consider as 0. But can you say it is correct? No, it is not correct. So what is to be done? So it has to be changed later. Yes. Similar to that, program C. Coming to the program C, again same label, NDA minus list A plus list C. But here, the list C value we knew because list C is defined in this control section. Where it is defined in the location 0030. And NDA minus list A That value we do not know. So for NDA minus list A, the values consider 0. So 0 minus 0, 0. 0 plus list C values 0, 0, 3, 0. So what is the object code we got? 0, 0, 3, 0. So the object code generated by the assembler is 0, 0, 3, 0. So when the object program is generated from the assembler, the object program for program A, program B, and program C would be like this. So this is the object program for program A. This is for program B, and this is for program C. So which has header record, text record, modification record. Apart from that, define record and refer record. So the defined record, which lists the symbols which are all defined in program C. Similarly, if you look at program B, D denotes defined record, which has the symbol which are defined in program B, that is list A, list B, and end B. Similarly, if you look at the object program, program A, defined record consisting of list A and end A. And coming to the R refers refer record. In the list, we can find list B, end B, list C, end C. So by seeing these symbols, we could make out these are external references. Similarly, if you see the program B, now you are seeing the program B. If you look at the refer record, list A, end A, list C, end C. Now you could see the program C, wherein the refer record represent list A, end A, list B, and end B. So we can see the different symbols which are defined and which are used. So let me go back to the program A, object program of program A. So which has header record, defined record, refer record, text record, modification record, and also the end record. So now when you see the modification record, there are number of modification record which represent there is a modification to be done in the object program, especially in the object code in few places with respect to the address mentioned over there. Now I'm going back to the program A. So now if you look at the starting address of the program, the starting address mentioned as 0. So assuming 0 as a starting address, where do we find the reference for? Which is there in the location 0054. Now in 0054, we got the object code as 0014. The 4 zeros followed by 14. 000014. This is the object code we got for the address 0054. So in the memory location 0054, the loader will be able to store the object code. But before storing the object code into the memory, it has to do the linking process. So when it is doing the linking process, so it has to deal with the program relocation as well. So it performs relocation, it performs linking, then it goes for loading process. So now when you see the value, that is object code, it needs the linking process. If there is a relocation, that is also to be done. So the object code needs some modification. When the object code needs modification, which is represented in the modification record. So in which address the modification has to take place? In the location 0054, because in that location this object code is to be stored. So whatever there in the 0054, in that memory location, the object code needs to be changed. So the instead of 000014, so there should be some value which needs to be changed. So what changes has to be taken place? We were not knowing the value of list C. So assembler assumes 0 for list C and it got the object code as 000014. But the list C value has to be added. List C value has to be added. So if it comes to know the value of list C, then it has to be added. Where it has to be added? In the location 0054. And how many bytes to be changed? As I already told you, the length of the bytes which needs modification can be represented in the half byte. So here we have 6 digits, that is 000014. So 6 digits, each digit will be taking 4 bits. So each digit has 4 bits. 4 bits are nothing but half byte. So 6 half byte would be the length. Now for the program A, when you see the object program, there is a modification record and it denotes what changes need to be done. That is what shown in the object program. In the modification record, the second modification record, if you see M followed by 000054. That 0054 is nothing but the address. This is the address where the modification has to be taken place. And 06, that tells you what is the length. That is the length of the changes, the field to be changed. That is 6 half bytes. Then what is to be changed? The list C value should be added. That is why there is a flag plus and there is a symbol list C. So this information is provided by the assembler to the loader. So the loader has to take this information. So it understood that it needs to be changed. The record needs to be changed. The object code needs to be changed. And what has to be done? Its information is available. So according to that, the loader has to perform the linking operation. Right. So now, same way for the remaining program B, program C. So all these places we are having one or other modification records would be there, and it gives you the entire information about what is to be changed, how long it, what is the length to be changed, length of the address field to be changed, and what is to be changed, whether it is to be added or subtracted. All this informations would be available in this. That's how we have the modification record. Now, so the real linking process happens here. Now, when the program is loaded into the memory, which means it has to know what is the load address. It means where the program is going to be loaded. So the loader has the address where the program needs to be loaded. So each and every program has the starting address, that is a load address. So program A is given with the address 4000, 4000. Let us say 4000. Now, what is the length of the program A? 63. So, continuous to program A, the next program, that is a program B, and continues to that, program C will be stored. So program A, program B, and program C. So the first program is program A, second one is program B, and third one is program C. If you see the length of program A, starting address plus the length of the program A, that gives you the starting address of the program B. Similarly for the program C also. So now you can see the load address for the different control sections, that is program A, program B, and program C. As you would have noticed one thing from these program. So what is the starting address of the program A? It's mentioned as 0. What is starting address of program B? It's mentioned as 0. What is the starting address of the program C? It's mentioned as 0. So assuming as 0, the assembler has created object code for each and every statement in the program, in the control section. So for the program C, for the program B, and for the program A. But is it possible all the program will be stored in the location 0? No, it is not possible. So it will be having different address. So as we knew that, definitely it will be having the different address. So it follows the relocation. Now, when you have this program A, program B, and program C, each will be having the loading address. It is not 0. It will be having the different address. When you have the different address, then automatically the remaining values also will be changed. Say for example, if you take the list A, list B, and list C. Now, I'll just go back to the program A. So program A, list A is defined in the location 0040. List A defined in the location 0040. When the starting address of the program is 0, it is assumed to be 0. When it is 0, the relative address of the list A is 0040. But what is the actual address of program A? The actual address of the program A is 4000. So now what is the actual address of the list A? Program A plus 0040. So what is the address of the program A, that is starting address of the program A, plus what is the relative address of the list A, that gives you the actual address of the list A. So 4000 plus 0040, that gives you 4040. Similarly, we can take it for list B and list C also. When you take list C, the program C's starting address is 40E2. What is the relative address of list C? According to program C, when it was having the starting address 0, the relative address is 0030. Whereas now the program C starting address is 40E2. So what we are supposed to do? We have to add 40E2 with 0030. That gives you 4112. 4112 is the actual address of list C. This is the actual address of list C. Now, you all the program coming to the loading part, wherein the loader loads the program and it loads each program, each control section in a different location. After knowing the load address, the actual address of individual symbols, that is the external reference, will be identified. Once it is identified, then this has to be placed in the respective places. how and where. Say for example, in program A, we have taken then a label REF4. What is the expression for the REF4? NDA minus list A plus list C. So what is the value was assigned for NDA minus list A plus list C in program A by the assembler? It is 0000014, because the list C value, we don't know the value of list C. So only by considering NDA and list A, the values been derived. That is 0000014. This is a value which is taken from this expression, but this was not the proper value. The reason is the list C value was considered as 0, and the actual value of list C is not considered. Now, in the modification record, if you look at the slide, which shows the modification record for this particular label, the object code which needs modification, which is represented in the modification record. So modification record 000005406 plus list C. So if you know the actual value of list C, what is to be done? With the existing object code, the value of list C needs to be added. When the value of list C needs to be added, then we will be getting the actual object code. So what has to be modified? The list C has to be added with the existing one. This modification has to be taken place. So if there is a relocation happens by using this modification record, the loader will understand that something has to be done, some changes has to be done. What changes has to be done? That is given in the modification record. So taking that information, it does the linking process because there is a relocation. So now what it does, so 0014, with that the actual value of list C is added. What is the actual value of list C? 4112. That is being added with the existing object code. So the existing object code was 000014 plus 4112 will be added. So that gives you 4126. So the preceding zeros is not kept here. So 004126. This is the object code after doing the linking process. Now the same linking which is shown in the figure. So this shows the memory location and where exactly the program A, program B and program C is stored. So if you look at the memory address and the location 4000, program A is stored. In the location 4063, program B is stored, and so on. So this is the entire memory which shows the loading of program A, B and C by the loader. So this diagram which shows whatever we have done, the linking process with the diagrammatic representation, we can understand. So we have program A, program C. So the object code for object program for program A and program C is being given. So in the object code, only the header, text and modification record, which is very much required, only those few instructions are given. So the program A consisting of text record and modification record. The program C consisting of the defined record and the header record. So program A, in that header record, that has the name of the program, that is program A. And if you look at the text record in program A, which has the starting address, that is 00054, and we have the object code that is 00014 that is shown in the rectangular box. Now this is the object code for the label REF4. So for the label REF4, the object code which was generated by the assembler in the object program is 000014. But as we knew that this is not the actual value, so this needs modification. Now if you look at the program C, in program C there is a header record that denotes that's a program C, and there is a one more record D which shows the defined record, the symbols which are defined in the control section, that is a program C, which are listed in the defined record. So obviously there is a list C and which has the relative address 000030. Now when the object program needs to be loaded into the memory, it has to be stored in a different location because 0 is not the actual location for the program C. So which is stored in the location 40E2. So this is the location, the load address which was allotted for program C. Now to get the actual address of list C, the program C load address will be added with the relative address which is from the defined record. So defined record which has the symbol name and relative address. So the relative address for the symbol list C is 000030, and we add the 0030 with 40E2, it's nothing but load address of program C. When you add these two, we'll be getting 4112. That is the actual address of list C. Now we got to know the value of list C. So what has to be done? The loader will perform the linking process, because the loader which comprise most of the loaders which comprise linker also. So the linker performs linking process. So the actual address of list C will be added with the existing object code that is meant for REF4. So the label REF4 which is in the program A, which has the value 00014, with that value the 4112, that is the actual address of list C, will be added. Once it is added, then we will be getting the value 004126, which is in the right hand side. So if you look at the right hand side, the box which is having the value 004126 for the REF4. So this is the actual value for the label REF4. After doing all the linking process, this is the actual value, actual object code for the REF4. So when the assembler creates, it creates the object code based on what information is provided in the program. After that, if there is a change in the starting address, accordingly that has to be reflected in the object code. That's where the loader will take the responsibility to do this process. So that is what we get. 004126 is the actual value for REF4, which is stored in the location 4054. Why it is 4054? Because when the starting address was 0, then the address where the object code is stored is 0054. But now the program A starting address is changed into 4000. So obviously in 4054, the real object code, the actual object code will be stored. That is what exactly you could see in the diagram. So this is what the linking will happen when you find the the modification record, when you have any relocation, program relocation, which is happening, that will be processed by the loaders and linkers. So this entire control section, which is representing the linking process. So now we'll move on to the third topic under the machine and dependent features of the loader, that is algorithm and data structures for the linking loader. So before moving to this, so there are two important things under the machine dependent features. One is a relocation and another one is a program linking. As the loader performs loading, relocation and linking, so whatever we have seen, that is relocation and linking. So the loading process, once it is done, the loading process will happen. That is also mentioned in few cases. So in the few examples I have shown you, the loader which is loading the respective object code in the places, in the locations. That is what the program A, program B and program C, when which is the load address is mentioned, the loader which is going to store or load the programs, the control sections into the respective places. So with this, we'll wind up this session. We'll start with the new topic in the next session.